run. All right, getting ready for the Chapter 5 test here. These problems are off the Chapter 5 review packet. And the first one I'm going to show is number 9, which says, if 85% of teenagers ages 16 through 19 drive a car, use the binomial probability formula to find the probability that exactly 16 out of 20 drive a car. So, you're wanting the probability of exactly 16 people driving a car. So that's your x. Whatever you're trying to find the probability of, that's your x value. Now it says 16 out of 20. So your n is going to be 20 in this problem. Okay, this is number 9. So the formula says take n factorial, so that would be 20 factorial, over n minus x factorial, so 20 minus 16 would be 4 factorial, and then x factorial, which is 16 factorial. You notice these two bottom numbers will always add up to the top number. That's a good way to kind of check your work. 4 plus 16 is 20. Then your probabilities come into play here. There's an 85% chance that if you randomly pick a teenager that they're going to drive a car, because it says 85% of teenagers drive cars. Then you're supposed to take that to the x power, so to the 16th power. So this is your p-value, which is the probability of success if you're trying to pick a person that drives a car. Q is the probability of failure, which would be 1 minus 0.85, 0.15, so that's what comes next. And that power is n minus x, so 20 minus 16 is 4. Again, notice that the two exponents add up to 20. That's kind of a way you can kind of, once you get done, kind of look at it and see if you think things kind of match up the way they should. Now this is really just the combination formula. What we're really doing there is you're finding how many ways you can choose 16 out of 20. Okay. So you could use that shortcut on your formula to get this answer. Or you can just type it in like you see it. So just type that in your calculator, and then it comes out to 0.182. Do I need to show how to type that in, or not? Okay on that? Okay. All right. Next one I heard that somebody wanted. Any other questions about 9? Somebody else wanted to do number 5. 5 says the number of water skiing accidents on the Lake of the Ozarks follows a Poisson distribution. The probability of an accident is 0.008. So our p-value here is our small p is 0.008. So when you go out boating, it's according to this, water skiing, you have an 8 out of 1,000 chance of getting in an accident. If there are 4,000 water skiers, that's our n. Total number of water skiers on the lake during a month. Find the probability there's going to be 30 accidents. Again, they're wanting the probability of 30. So x is your 30. 30 is x. Now this is the Poisson distribution. The formula for that looks like this. The probability of x accidents, when the average is lambda accidents, equals e to the negative lambda times lambda to the x over x factorial. That's the Poisson formula for probability. So what we have to figure out is our lambda. Well, if there's 4,000 water skiers out there during a month, and 0.008 of them are going to get in an accident, so multiply 4,000 times 0.008, there's an average of 32 accidents out of those 4,000 people. So that's your lambda. The Poisson distribution is used when you have a large amount of time, area. So you could be looking at a large area of land, a large volume of the water. In this case, we're looking at a large number of water skiers. It's also used when the p-value is small, when the probability of an accident is small. Or like if you're looking for a rare animal in the ocean or a rare plant out in the desert or something like that. When the probability is small and the area or amount of people is large, that's when this formula is useful. So now we just take e to the negative 32 times lambda, which is 32 to the x, which is 30, over x factorial. We're trying to figure out the probability of 30 accidents when we know the average is actually 32. Type that in your calculator. Should get 0.068, which is the same as 68 over 1,000. So there's a 68 out of 1,000 chance that there's going to be 30 accidents when we know the average is 32 accidents. Any questions about that? Okay, any others you want me to go over?
Can you do 6B?
6B, yep. Number 6, just do part B here. Student government at Primrose College consists of 10 women, 8 men. If 6 members are randomly selected, so select 6 members. What is the probability of getting at least 4 women? Or at least 4 of them are women. So we're trying to find the probability of at least 4 women being on this committee or in the student government. You're picking 6. So at least means the least number of women is 4. So you could have 4 women, 5 women, or 6 women. All right? So we really need to add those 3 numbers together. The probability of 4 women, or, which is plus 5 women, or 6 women. Now you might say, well, if it says at least, you told us to use complementary events. Well, we could, and I'll show you that when I'm done. That's another way to do it. But for 4 women, we're using the hypergeometric formula here. You're going to try to choose 4 women out of 10. Which means how many men would you be picking if you pick 4 women?
2 out of 8.
Yeah, there's 6 people total you're choosing, so you'd be picking 2 men out of 8. And then your total, you'd be picking 6 people out of 18. So that would be your probability of getting exactly 4 women. For 5 women, you'd be picking 5 women out of 10. So how many men would you be picking? What, one man out of 8. Again, your total down here, you'd be picking 6 people out of 18. 6 women, choosing 6 women out of 10, which means you'd be choosing no men out of 8. How many ways can you do that? Yeah, that answer's choosing 0 men out of 8, that's 1. It's only one way to choose nobody, and that's don't choose any of them. Okay? So that you could just leave that off, because that's a 1 right there. Multiplying by 1 won't really affect the answer. Again, you're choosing 6 out of 18. So what you're going to do is find these 3 decimals, and then add them together. And that should come out to 0.437. Now, the other way to do this. Well, I guess any questions about this way before I show the other way? You could instead do 1 minus the probability of the complement. What's the complement of getting at least 4 women? 0, 1, 2, or 3 women. So you could say, let's add up the probability of getting 0 women plus 1 woman plus the probability of 2 women plus the probability of 3 women, and subtract that from 1. That would also give you the same answer. Or a third way you could do it, you could just do 1 minus the probability of 0 women minus the probability of 1 woman minus the probability of 2 women minus the probability of 3 women. Basically just distribute that minus through, subtract them all off. That would also give you the same answer. So it's really like 3 ways you could do that problem. Any questions on that?